Semiconductor digital verification engineering plays a crucial role in semiconductor manufacturing, ensuring that digital designs function as intended before being fabricated into physical chips. Digital verification engineers work closely with design engineers to validate and verify digital circuits and systems using a variety of simulation, formal verification, and emulation techniques. Their work is essential for identifying and fixing design errors, ensuring reliability, and improving the overall quality of semiconductor products. By meticulously testing digital designs at various levels of abstraction, from individual blocks to full system on chips, digital verification engineers help to accelerate the development cycle and reduce time to market for new semiconductor products. Digital verification engineers employ a variety of methodologies and tools to perform their tasks. Standard verification methodologies include Universal Verification Methodology, UVM, which provides a standardized approach to verify complex SoC designs, and Assertion-Based Verification, ABV, which uses assertions to specify design behavior and identify deviations from expected behavior. Digital verification engineers also utilize simulation tools to mimic the behavior of digital circuits, enabling them to test designs under different conditions and scenarios. Additionally, they may use formal verification tools to prove the correctness of specific design aspects mathematically and emulation tools to run real-world scenarios on hardware accelerators, providing a more accurate representation of how the design will behave in the final product. Effective communication and collaboration are vital for semiconductor digital verification engineers. They work closely with design teams to understand the intended functionality of the digital circuits and systems they verify. This collaboration is essential for creating comprehensive verification plans that cover all design aspects. Digital verification engineers also communicate regularly with other stakeholders, such as project managers and quality assurance teams, to provide updates on verification progress and highlight potential issues. By maintaining open lines of communication and working collaboratively, they help to ensure that the final product meets all specifications and quality standards. The semiconductor industry is fast-paced and constantly evolving, requiring digital verification engineers to update their skills and knowledge continually. They must stay abreast of the latest verification methodologies, tools, and best practices to verify complex and innovative digital designs effectively. It often involves participating in training programs, attending industry conferences, and engaging with professional networks. Additionally, digital verification engineers must be adaptable and ready to take on new challenges as technology advances and design complexities increase. Their ability to learn quickly and apply new knowledge is crucial for maintaining the high standards of quality and reliability expected in the semiconductor industry. Semiconductor digital verification engineers' work profoundly impacts the quality and reliability of semiconductor products. As the complexity of digital designs continues to grow, the role of digital verification engineers becomes increasingly critical. They are crucial in identifying and fixing design errors early in the development cycle, reducing the risk of costly post-fabrication issues. The demand for skilled digital verification engineers is mainly due to the ongoing need for more complex and reliable semiconductor products in various industries, including computing, telecommunications, automotive, and healthcare. Their expertise ensures that semiconductor products meet the stringent quality and reliability standards required in today's technology-driven world, making them invaluable contributors to the continued innovation and success of the semiconductor industry.